Alright. So, let's go. Last call untuk kelas 4C5. Muhammad Alif ada? Muhammad Alif Luqman? Tak ada. Nakudin? Tak ada. Okay, so tak ada lah. Consider not attend today. Alright, thank you very much. Okay, so next is kalau last week I told you that Dr. Mazlina will come back after Hari Raya, right? But unfortunately, she got an MC until early of May, so meaning that I need to teach you until that lah. Okay, so kalau untuk hari Selasa ni, I punya kelas is fully kelas lah daripada pagi 8 sampai pukul 6. So I would like to ask you if you have siapa yang available on hari ni tapi jam pukul 4 sampai pukul 6. Siapa yang tak available? Siapa yang tak available boleh tak you letak komen dalam chat group now? Please.
Madam. I think untuk kelas 4A4 memang semua tak available sebab kita orang ada kelas structure.
Okay, 4C5? 4C5 ada kelas 4 to 6, 4 to 6.
4C5 sepatutnya 4 hingga 6 tak ada, tapi tak sure kalau ada sesetengah yang jadual dia lain.
Okay, faham? That's why I tanya ada tak? Siapa yang ada kelas dari 4C5 yang ada kelas pada pukul 4 hingga 6? Ni Sylvia, Nurin, Nur Izian, Muhammad Hazim ni daripada kelas 4C5. Okay. Do you have a class on Tuesday morning? 8 to 9? 8 to 10, sorry. 8 to 10 ada? Itu 10 pun ada. Lagi kelas I. Okay, hari Rabu 2 pengayuh 4 ada? Rabu 2 to 4.
Ada doktor.
Okay, it's quite struggle for me lah menyebabkan I punya ATA ni makin banyak lah sebenarnya. Okay. Alright, it's never mind. So we just proceed as what have been planned for your class. Okay, so let's we continue with our lecture today. Can you see my slide?
Yes, madam.
Okay, so last week we already started learn about the basic concept on the kinematics of particle where we focus on the rectilinear motions of particles. Okay, so this is the learning outcome for this topic, for first topic, where you should be able to find the kinematic quantities. Okay, bila sepasal quantities ni, kinematic quantities ni dia melibatkan apa? Dia melibatkan positions, velocity and acceleration. Under kinematic, kita study pasal ni je. Tanpa mengambil kira any effects of forces. Okay. And again, focusing on the rectilinear motions, you need to understand that the particle should traveling along a straight path. Okay, when we talk about the rectilinear motions. Okay, when we talk about rectilinear motion, the particle will travel along a straight path. Okay, and then from these kind of conditions, you should be able to determine the motion of particle. Dia kata motion of particle is about the x a function of t, v is a function of t, and a is a function of t. Okay, alright. So this is the learning outcome for this topic. Okay, yang mana for this topic cover. Supposedly kita dah habis last week lah. Okay. But because we have a part to introduce about the OBE and so on, so we little bit drag on from our schedule. Okay. So in order to study about the kinematic equations, okay, kinematics quantities, we will use kinematic relationship, okay, to solve for all kinematic quantities that mentioned just now. Okay. And then when we are talking about rigid body, okay, we sometimes prefer to analyze as a particle. Okay. Dan kita tak boleh suka-suka analyze as a particle lah. Kita hanya boleh analyze as a particle bila kita boleh consider hanya movement on the center of mass center of mass only. Okay, yang mana kita neglect rotations. Okay, dalam particles kita tak ambil kira rotation. There's no rotation occurs. Okay, dia cuma ada translation sahaja. Okay. Alright, so from this problem, okay, in this topic, basically what we are trying to do is we want to derive and determine, okay, function x, function v, and function a, which is later on we can calculate any specific value of x and a any time of t. So last week with this kind of situation, you are given, okay, alternative function ni maksudnya dia refer kepada position function. And you are given position function. Okay, so this position function can be determined or obtained through the measurement. Or you conduct an experimental work, you do site site work yang mana you collect a data, then you can produce a function in terms of positions. A position function in terms of time t. Okay, once you have the position function of time t, then you can relate with kinematic equation or kinematic relationship to define the velocity and also define the accelerations. Second type of problem is when you are given a constant accelerations ataupun accelerations lah, sama ada constant value ataupun any value of acceleration functions. Okay, so from here we are trying to look at how can we define the velocity function and position function when we are given accelerations. Okay. Alright, so I skip for this part. Okay, ni condition between kinematics and kinetics. Okay, ni focus on forces, ni tak ada forces. Okay. Alright, and then when we talk about rectilinear motion, again, we study about positions, velocity, and acceleration of a particle as it moves along a straight line. Later on, when we finish for the rectilinear motion, we will study about the curvilinear motion. Again, we will study about the position, velocity, and acceleration where the particle move along a curved line, whether in 2 or 3D. Okay, I go very quick for this part because we already covered last week. Okay, and then we continue with study about how can we define the positions. Okay, which basically the position can be defined once you have the position coordinate. Okay, once you have the coordinate, once you have the coordinate exists. Okay, so this the coordinate exists, then you have the origin. Once you have the origin, then you can find the position of the particle either in terms of vector form or in terms of scalar form. Okay. All right. So from the positions here, you can use when they move from one point to another point. Okay. Yang mana contoh, for example, daripada position 4 meter kepada 6 meter positions, then later on you can calculate the displacement. Okay, so for this case, bila kita ada change in positions, but in this case we have no data with time t. Okay, ini we talk about positions. Okay, so when we have this kind of data, you can determine displacement. Okay, so to calculate displacement, you can calculate based on the final distance minus with initial distance. Then you can calculate displacement. Okay. And by using the positions data, you also can calculate total distance travel. Yang mana total distance travel, dia hanya ada satu form sahaja, which is in positive scalar form. Okay, that represent the total length of the path over which the particle travel. Alright, this is about positions. But when we want to study about motion, okay, when we want to study about motion, first, check first apa yang you nak study, rectilinear or curvilinear. Kalau kata rectilinear, particle moving along a straight line. Okay, and then when we study about motions, okay, again you must make sure that you have the position coordinate. Okay, sebab bila ada position coordinate ni dia boleh tahu di mana kedudukan you punya position, sama ada on the right hand side or left hand side, on the positive or negative side. Okay, sebab positions in motion study dia adalah vector. Okay, yang mana dia ada magnitude and direction. Itu position. But when we talk about motions, okay, the motion of a particle is known if the position coordinate for particle is known for every value of time t. Contoh, kat sini dia nak tahu at p equal to 4 meter, t equal to what? Okay, so if you have this kind of data, then you can study about motions. Okay, then you can study about motions. Alright, so in order to study about motion, the position here can be expressed in the form of functions. Okay, can be expressed in the form of function or in the form of a graph x versus t. This is for the position coordinate. Yang mana position for okay. So one we can study about the velocity. Okay, so this is the data in terms of the graph x versus time t. Okay, then one we have the position functions. All right, then when we have a data of position in terms of a time t, okay, then when they travel from one point to another point, then we can calculate the velocity. Okay, then we can calculate the velocity. Again, the velocity only can be calculated when the positions has been recorded at every value of time t. Okay, at every value time of t. Okay, all right, so when you have change in position at t to t plus delta t, then we can calculate the velocity. Again, velocity is vector, ada magnitude and directions. Okay, we have two equations that we can use here that involve with velocity. One is average velocity that involve with delta t value. And then we can calculate the instantaneous velocity or velocity, where here we consider that the delta t here is very small. Okay, the time duration is very small, which is close to 0. Then we will calculate the instantaneous velocity as the time derivative of positions, yang mana dia merujuk kepada slope of the graph in the position graph. Okay, so this is the kinematic relationship that you need to know. The first kinematic relationship that we can use in order to calculate the velocity, which is v is equal to dx over dt. Don't forget, positive is a vector. It can be in positive or negative value. Okay, and then in the velocity, you also can sometimes heard about the speed. Okay, speed tu apa? Speed tu adalah magnitude of the velocity. Okay, so from this speed, you can calculate average speed. Okay, kalau speed dia tak ada direction, dia cuma ada magnitude sahaja. Okay, so then you can calculate the average speed by using this formula, total distance travel over delta t. Okay, so in conclusion, the velocity here, okay, the velocity here can be calculated using this derivative. Okay, v is equal to dx over dt, where this is the kinematic relationship that you need to know when we study about motion. Okay, so how can we apply this? You need to have x function first, which is here. For example, we are given 6t square minus t cube. So we apply this kinematic relationship, dx over dt, meaning that you have to differentiate this function with respect to time t. Then you will get the new equation or new function, where this function is represent velocity functions. Okay. And then from the velocity, when it moves from one position to another positions, we varies in velocity, either increase or decrease of speed, then you can have acceleration or decelerations, positive acceleration or negative accelerations. Okay, nama lain untuk negative acceleration adalah decelerations. Okay, alright. So to calculate the accelerations, we apply another kinematic relationship, which is dv over dt. Okay, so this is the kinematic relationship in order to calculate acceleration, in order to derive the acceleration functions. Okay, in order to derive the acceleration function. So to apply this kinematic relationship, again, you must have the velocity function first, then you can apply it to get the acceleration functions. Okay, all the function that you have here, actually, we can get the velocity value, acceleration value, and the position value at any value time of t. Okay, so this is an example where you can see that based on the function that we had derived before, okay, then you can get any value of x, b, and a when you are required to get at t equal to 2 seconds. Okay, so there's another thing that you need to remember, that you need to understand. Okay, there are two conditions that you need to know, where when a is equal to 0, v will be equal to v maximum. And when v is equal to 0, you will get x equal to x maximum. Please take note about this. Okay, this is something that in the problem, they will not give you the information, but you need to know. When they mention that determine the maximum over the velocity, we know that is occur at the a equal to 0. Okay, all right. Any questions so far? Ada soalan? Okay, so in this case, kita cover untuk for the first type of problem yang mana we are given x function. By given x function, kita dapatkan velocity, kita kena dapatkan velocity function first. Okay, daripada velocity function ini yang mana kita calculate based on dx over dt, you akan dapat velocity function. Then later on, you can calculate velocity at any value of time t. And then later on, to get the acceleration at any t value, you need to derive the function first. Okay, where we can derive by using this kinematic relationship. Okay, so from x to a, the process that you need to involve is the differentiation process. Okay, all right. So last week we stopped here. Okay, am I right? Betul ke?
Betul.
Okay, so now we want to look on how can we define. Again, kita masih lagi nak cari berapa nilai A at t equal to 2 second. Berapa nilai V when t is equal to second. Okay. When t equal to second, berapa nilai V? When x equal, when t is equal to 2 second, where is your positions? Okay. So we still talk about to determine the value of A, V, and X. But basically, in order to study or to determine all these kinematic quantities, you must have the function first. You must have the equation first. Okay. Just now we studied about by given position function, we differentiate it to get velocity and acceleration. Now the second condition is when you are given acceleration function first. Okay. You are given acceleration function. Where can we get acceleration function? Normally, this function can be obtained when you study under kinetics. Okay, under kinetics, but we not cover yet, right? So now we're assuming that we already have this function. Then now we have to think about how can we get the velocity function and positive functions. Okay. So in this case, before we go further into the solutions, okay, into the how can we solve it, we need to understand that the accelerations here is divided into 3 different classes. Okay, kita ada A as a function of time t, kita ada A as a function of position, kita ada A as a function of velocity. Okay, so now let's look here. How can we define the functions of the velocity and the positions when we are given A functions? Okay, so basically kita sampai mana dah sebenarnya last week? Semua tidur ke? Tidur semua. Ya, cakap seorang-seorang ke ni?
Rasanya nampak integrate.
Yang bawah tu.
Habis integrate.
Okay, now we assuming that first we are given A as a function of t. Okay, we have A as a function of t. Okay. If just now, if you are given x a function of t, to get v as a function of t, we need to apply dx over dt. Okay, if you want to get a as a function of t, we have to apply dv over dt. Okay, so now we are given a is a function of t, or a is a function of x, or a function of v. Okay, then we want to get velocity functions and position functions. So velocity function can be expressed either in terms of positions or in terms of time. Kalau position, only in terms of time. Okay. Alright. So before I go further into explaining you in detail how can we go up to this level. Okay. Now I tell you first, if you are given a as a function of time t, you can derive for v as a function of t, and you also can derive for x a function of t. Okay. But if you have a as a function of x, you only can derive for v as a function of x. Okay. And if you have a as a function of v, you can derive v as a function of t. You can derive x a function as a function of t, and you also can derive v as a function of x. Okay. So this is the first thing that you need to know first. Okay. Daripada a, function apa yang you boleh derive. Okay. So as I highlighted here, when you are given a as a function of t, you can derive for v as t, x as t. Okay, and for a as a function of x, you can derive velocity function in terms of x. And for a as a function of v, dia boleh derive ketiga-tiganya sekali. But how can we derive these functions? Okay, so to derive this function, you need to first call all the appropriate kinematic relationship that can be used for the given accelerations. Okay, for example, here, we are given a as a function of t, and we know that kinematic relationship that relate to this one is dv over dt. Okay, we know that a as a function of t can be defined based on kinematic relationship of dv over dt. Okay, so now you need to know that in order to get a to v, v to x, we need to conduct integrations. Okay, we need to conduct integrations. Okay, tadi yang ini kita kena conduct differentiations. Okay, yang ini kita conduct integrations. So before we can conduct this integration, you must have the equation to integrate first. Okay, so now what we are doing right now is we want to develop an equation where we can do the integrations. Okay, right. So from this kinematic relationship, what can we do is we have to rearrange it. We have to assemble according to same parameters. Okay, so as you can see here, kita ada parameters t dekat sini. So kita kena bawa derivative dt to the right hand side. Okay, so therefore you will have new arrangement of equation. dv is equal to at dt. Okay, you will have dv is equal to at dt. As you can see here, we have derivative at both sides. Okay. So now bila kita ada derivative, dekat sinilah bermulanya integrations. So kita introduce integration sign. Okay, sebab kita nak change derivative tu kepada variable. Alright. So now we introduce integration sign here. Okay, then we integrate lah. But before that, before we can do the integration, you must put the limitation first. Okay, so the limitation, since that we are talking about dv, the limitation is from initial velocity to final velocity. And then here we are talking about dt. Now the parameters here, the limitation here is about time, which is from 0 to t. Kenapa sini 0? Kenapa bukan t not? When we are talking about initial velocity, bermaksud dia berlaku di initial velocity ke atau initial position ke, dia mesti berlaku apabila t is equal to 0. Okay. And then the v naught and s naught ni is not necessary is equal to 0. It based on the problem. Okay. Ada masa dia punya initial velocity tu ataupun initial position tu ada value. Ada masa dia tak ada value. Bergantung. Tetapi bila sebut pasal initial value, dia mesti berlaku apabila t tu adalah equal to 0. Okay. Right. So once you have this, then you can proceed with the integrations. Okay, yang mana the result that you can get from here is V naught to V equal to integrations A T dt from 0 to T. Okay, so the result that you get here, okay, ni is equal to what? V minus V naught equal to integration AT dt from 0 to T. Okay, so this is the result from the integrations, okay, where we want to get the function of V. So we need to bring the negative V naught to the right hand side. So therefore your final function or equation will be V is a function of T. Kenapa yang boleh letak V as a function of T? Sebab kat sini semuanya dalam sebutan T. Equal to V naught plus integration 0 to T AT dt. Kenapa I tak ada result on this part? Because I don't have functions. Okay, so I tak boleh nak buat integrations. Okay, so this is how we derive a function of VT here. Okay, kita derive function of VT yang mana you kena tahu you akan dapat satu function dan later on bila dia kata determine the velocity when T is equal to 5 seconds. So just ganti masuk je lah nilai T on that function, then you will get the velocity. And then later on the question asks you determine the position when T equal to 2 seconds. So macam mana kita dapatkan position sekarang? Kita kena adakan function position. So how can we get this function position? We need to derive it from the kinematic relationship. Okay, yang mana based on the value of VT. Okay, sekarang ni kita kena based on, sekarang ni kita nak dapatkan X as a function of T. Okay, from velocity. So how can we get these functions? Okay, the procedure is again the same as what we have done just now. Okay, kita ada VT yang mana kinematic relationship for VT is equal to dx over dt. Okay, and then we do like this, we rearrange it supaya kita boleh buat integration. So kita bawa dt ke sebelah lah. So you akan ada Vt dt equal to dx. Then we introduce the integration sign. Okay, this one from x naught to x. Okay, and this one from 0 to t. Okay, so from here you can produce another function where this can be used to determine position at any time t. Okay, so dapatlah satu function from these derivations. Okay, so this is how we derive a function of velocity and positions when you are given a as a function of t. All right. Again, now next, let's we look when you are given a as a function of positions. Okay, so the procedure is sekarang ni kita hanya boleh derive untuk velocity at any value of position sahaja ataupun acceleration at any value of positions. Okay, you tak boleh derive position functions. Okay. Alright, so now in this case, again, we start with select or choose the appropriate kinematic relationship. Okay, so in this case, okay, dia tak ada direct yang kita boleh guna based on what we have done before, based on what we have studied before. Okay, yang kita ada sebelum ni hanyalah dx over dt and dv over dt. So bila kita ada a as a function of x, kita kena ada derivative of x. Okay, so kita kena introduce derivative of dx ni. Okay, so how can we introduce this? Right now, we will work with these two kinematic relationships. Okay, where first we have v equal to dx over dt. Then the second one we have a is equal to dv over dt. So this is the main kinematic relationship that we have to look at. But then we cannot proceed because we don't have dx here. So we need to change dt to dx. So how can we change it? By considering this kinematic relationship. Okay, then we get the expression for dt in terms of dx. So we rearrange it. This one akan bawa ke sebelah, VB akan bawa ke V akan bawa ke bawah. So you akan ada DT is equal to DX over V. So yang inilah yang you akan substitute into DT. Okay. So when you substitute into DT, the new equation that you will get is, okay, after substitutions tu, what you will get is A is equal to V dV over dx. Okay, so now this is another kinematic relationship that you need to remember. Okay, so we not only have dx over dt and dv over dt, we also have v dv over dx. So this is derived kinematic relationships. Okay, all right. So now based on this kinematic relationship, then we proceed as usual, where now we want to conduct the integrations. Okay. So to conduct the integrations, again, what should we do? Based on the AX equal to V dV over dx. So sekarang kita kena assemblekan all the same parameter at one side. Okay. So we have AX here, so we need to bring dx to the left hand side. So you will have AX dx equal to V dV. Okay, so now we can introduce the integration sign. Okay, as you can see here. All right, in order to get the velocity function, which is in terms of positions. Okay, you solve these integrations, then you will get the function of V in terms of X. Then stop. You tak boleh buat further derivation lagi dah. Sebab dia hanya boleh derive untuk V as a function of X only. Okay. Alright, so far so good. Any question? Ada soalan?
So far okay, Doctor.
Okay, now let's look when you are given A as a function of velocity. Okay, so when you are given A as a function of velocity, as I mentioned to you, you can derive these three functions. You can derive for V as a function of t, you can derive x as a function of t, and you can derive V as a function of x. Okay, how can we get this? All right, in order to get for the first two equation here of function, you need to equip your A function here with this kinematic relationship. Okay, disebabkan you nak dapatkan function dalam sebutan T, AV ini mesti relatekan dengan dV over dt. Okay, alright, so that's why you nampak dia ada two parts sebab yang ni dia akan fokus untuk dua ni. Okay, by considering dV over dt, you can derive for Vt and then later on you can derive for xt. Okay, so when come to this part, dia exactly sama macam kita buat on the first one tadi. Exactly sama. Cuma beza dia apa? Beza dia when you come to these equations. Okay, kalau tadi dia terus dV sahaja kan? Kalau sekarang tidak. Sebabnya apa? Kita ada function of V. Okay, yang mana if you look carefully here, as we know, bila kita nak buat integration, kita kena kumpulkan value-value yang kita ada ni mengikut parameter yang sama. Okay, so now we have dV over dt equal to AV. So kita tak boleh simply bawa dt ke sebelah dan kita proceed dengan integration. Cannot, because here we have variable V and then here we have derivative T. Okay, so you have to make sure that the derivative mesti berada sama dengan function yang ada variable V. Okay, so here in this case what we have to do, we have to exchange these positions. So AV bawa ke bawah, so akan ada dV over AV. Then dt bawa ke sebelah, dia akan ada equal to dt. Okay, then barulah kita boleh buat integrations. Alright, so integral over AV. Okay, so dia akan involve dengan ln, exponential and so on lah. Okay, so make sure that you have no problem to do the integration for that kind of function. Alright, so terhasil lah nanti velocity as a function of t. And then later on nak dapatkan position function, sama macam kita buat on this part. Sama, exactly sama on this part. Okay, sama macam these sections. Okay, To get x a function of t, you akan buat vt is equal to dx over dt. Then you bawa dt to the ke sebelah, dan baru you boleh integrate untuk menghasilkan position functions. Okay. Right now, to get the velocity function in terms of x, now we have to redo the derivations. Okay, kita tak boleh continue lah. Okay, kita redo from what? We take again, now for this part, we will follow on the second row here. Kita akan follow cara exactly macam second row ni, yang mana kita akan menggunakan kinematic relationship of v dv over dx. Okay, then kita assemblekan the function or equation into the same, with the same variable. So here we will have v dv over av equal to dx. Dan barulah kita boleh integrate. Integrate from v naught to v, integrate from x naught to x. Okay. So nanti terhasil lah velocity function in term of x. Okay. So far so good. Any question? Ada soalan? Ada soalan? Okay, if you have no question, let's we move on to the first sample problem. Okay, I assuming you have no problem lah. Okay, sebab semua orang pun senyap kan? Okay, so I don't want you just listen. Now I want you to think with me about how can we solve for this problem. Okay, so when we want to solve for any kind of problem or questions, okay, please make sure that you understand the statement or the problem given. Okay, and from the problem or statement given, then you need to be able to analyze what type of motion, okay, what is the additional information that you can give, and so on and so forth. Alright, you tak boleh simply terus solve the problem dengan menghafal cara step by step. Okay, nak menghafal step by step tu ada masalah, tapi you exactly follow, oh yang ni kena buat macam ni kena buat macam ni. No, okay. You have to be careful when you are trying to solve for any kind of problem in dynamic or static, because even though we are talking about the same procedure, same equation, but dia punya susun ataupun involvement of the combination of the equation to difference. Okay. Alright, so now for this problem is very straightforward. Okay, dia kata apa? A particle travels along a straight line to the right with a velocity of v equal to blah 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 meter per second, where t is in second, and also s is equal to 0 when t is equal to 0. Okay, so from this statement, try to bring the statement into a figure, the statement into a function ataupun mathematical equations. Okay, for example here, what can you explain here in terms of diagram? A particle travel along a straight line to the right. Okay, so bermaksud particle ni bergerak ke kanan. Okay, bila kita study pasal motion, kita kena define first kita punya coordinate axis. Kita kena define first our positive coordinate axis. Since the particle moving to the right, so we will assume that our coordinate axis to the right is positive. So you kena ada this coordinate axis. Okay, so bermaksud partikel ini bergerak dalam keadaan positif lah. Macam mana? Okay, dia bergerak ke kanan. With velocity v. Dia tak cakap initial, dia kata with velocity of v equal to this function. Okay, right, tulislah function tu. Okay, and then dia kasih lagi also s is equal to 0 when t is equal to 0. Macam mana kita nak describe in term of mathematical form? When t is equal to 0, s will be equal to 0. Ataupun cara lain dia apa? S 0, 0. Okay, sebab kita tahu function s nanti dalam sebutan t. Okay, so when t is equal to 0, position will be equal to 0. So this is the information that we have, and this is the illustration that we can produce for the problem. Okay. Next, we look on what the question that we need to solve here. Okay. So okay. So now they want to determine the position and accelerations of the particle when t is equal to 4 second. Dia nak cari di mana kedudukan positions tu apabila t itu is equal to 4 seconds. And then also, what is the accelerations when t is equal to 4 seconds? Okay, to get these two answer, you must have the function first. You can have the function as a function of t, and then you can have the function a as a function of t. Okay, so we are given v functions, but we want to get s function and a's functions. But what we have learned before, kita belajar daripada x kepada a kepada x. Kita tak belajar pula yang start daripada v. But it still can be done. Okay, now let me see here. Okay, we know that for what we have learned before. Okay, x to v and v to a, we have to differentiate dx over dt, dv over dt. Now we have a to v to x. We have integrate a, we have to integrate v. Okay, now kita diberi di sini. We are given v functions. Okay, we are given v functions. Now we want to produce s function and a function in order to get the position of s at 4 seconds and the acceleration at 4 seconds. Okay, so as you can see in this, in my notes here, okay, when we talk about from v to x, okay, from v to x, what should we do? We need to integrate v, okay, in order to get st function, we need to integrate vt functions. Okay, we need to integrate vt function. So how this is just random je lah. You kena go to specific as we did here. Okay, we have to follow the procedure that we have done here. All right, we need to get st function. In order to get st function, we have to integrate velocity, and then in order to get a function ni, from v to a, kita kena apa? Differentiate. All right, to get a as a function of t. Okay, we need to differentiate the velocity with respect to time. Okay, all right, so from this we can continue to solve the problem because we already got the ideas, okay, how to solve the problem. So this is something that you have to do first. Okay, you need to get an idea or plan or strategy, how can you solve the problem. Okay, so once you have this, okay, then we can proceed to solve the problem here to get the result. Okay, so in here, okay, as you can see, they start with solve for a problem that involve with acceleration because dia hanya melibatkan differentiation. Okay, benda yang simple. Antara differentiation dengan integration mudah lagi differentiations. Okay, so we are given v function. To get acceleration, we have to differentiate. Okay, so to differentiate, it's not a problem. It's very easy. Okay, you just differentiate v ni, yang mana bila kita differentiate, variable tu makin berkurang lah. So that you can get the result after you differentiate is equal to 4 minus 60. So this is a function of A dalam sebutan T. Sekarang ni dia nak A apabila T equal to 4 seconds. So to get the answer, we substitute T equal to 4 seconds into these functions. Okay. Alright, so when we substitute this T into this function, then you will get the result of A. Okay, mana result of A here, okay, equal to negative. Okay, equal to negative 20 meter per second square. Okay, bermaksud dia bergerak ataupun direction of this acceleration ataupun pergerakan dia dalam keadaan decreasing in speed. Pergerakan dia ke kanan tetapi berlakunya decreasing in speed. So terhasillah deceleration. So directions untuk acceleration ini mestilah ke kiri. Okay, this one had been mentioned last week. Okay, so this is the first one, determine the acceleration. Okay, the second one is to calculate the distance. Calculate the distance traveled in 4 seconds. So to calculate the distance here, you must have the position function first. Okay, you must have the position function first. Alright. So to get the position function, how can we derive it? Okay, sebab dalam case ni dia pergi dalam keadaan backward. Okay. Tadi pada X ke V, V ke A, differentiate. Now dia nak V ke X, kena differentiate, kena integrate lah. Okay, before we can integrate, you need to develop this one first. Okay, how? We know that we are given V function, then we have to call the kinematic relationship related to this one, which is we have dx over dt. Okay, we rearrange it. Okay, kita akan ada Vt dt equal to dx. Okay, bila dalam keadaan begini baru kita boleh integrate. Okay, integrate from T equal to 0 to T, x non to x. Okay, so we are given Vt function equal to this one. Okay, so then we can integrate. Once you integrate, you get this one. This is the result from the integrations. Okay, so now we can answer for the question. Okay, kita kena dapatkan nilai S apabila T tu equal to 4 second. But in this function, as you can see, dia ada S naught. Yang kita nak adalah S, berapa nilai S. So you need to know what is the S naught value here. Okay, it's not directly given, tapi dia mention. Okay, dia mention kat sini tadi. When T is equal to 0, S is equal to T. So T here kita substitute dengan 4 because this is question needs. Alright. So when we substitute 4, arrow. Okay, bila kata negative bermaksud dia to the left. How do we know? Because kita dah assume tadi coordinate axis kita ke kanan adalah positive. So bila negative bermaksud dia berada di left hand side. Okay. So this is how we solve this problem. Okay. Tak kisah dia kasi mana pun. Jadi you tahu kalau dia daripada X ke V, V ke A berlakunya differentiation. But if from A ke V, V ke X berlakunya integrations. Okay. Alright, that's all for this sample problem. Any question? Ada soalan? Okay, so if you have no question, before we move on to the next sample problem, let's we take 2-minute breaks. Okay. All right, so now we move on to the next example.